Is going to be the video where I go over problem number 4 from the chapter 6 examples. There's a lot going on here, many parts, but this is really good practice for dealing with the normal model and finding your percentages, like the area under the curve for z-scores, and getting used to the calculator. So when you watch this video, I highly encourage you to have a TI-84 next to you, or have your phone which has the TI-84 on it, hopefully, so you can make sure you're practicing pushing all the different buttons. So we're going to use this idea that the fuel efficiency for cars registered in Texas would actually show a normal model with a mean of 24 miles per gallon. All right, so let's write down our capital N for the normal model. And the mean, right, this is going to be mu and sigma, is 24 miles per gallon, and the standard deviation is 6 miles per gallon. So just sketching a normal model, which you've already practiced earlier on in this packet. So I want to go 3 standard deviations to the right, 3 to the left. So I'm starting with 24 in the middle. That's our mean. And as I move to the right, I'm going to add 6 each time. And then now I'm subtracting 6. Okay, so I'm not asking you to write the sentence here, but you've had practice writing the sentence where we're saying that according to the normal model, 68% of all the cars registered in our state, we would expect them to have between 18 and 30 miles per gallon for their fuel efficiency. 95% of those cars we'd expect to have between 12 and 36 miles per gallon, and then 99.7% of all the cars we would expect to be between 6 miles per gallon and 42 miles per gallon. So again, we'll answer it later on in this question, but like if you're somewhere in between 6 and 42, technically, according to me, you don't have an unusual fuel efficiency. But if your car gets less than 6 miles per gallon or over or above 42 miles per gallon, then that would mean that you have an unusual car in terms of fuel efficiency. Okay, so let's try letter B. And again, going to be using this formula pretty much on every problem to find a z-score, which is our data value minus our mean over our standard deviation. All right, and those symbols are important. In number 2, I believe, we used the same formula, but the symbols were different. We had y bar instead of mu, and we had s instead of sigma for standard deviation. Right, the idea being that one we were talking about actual data, and this one is using a model. So the notation should help you understand if it's real data or not. So we know that right in the middle, and I'm going to draw a little bit more than I normally would, but right in the middle is 24. So 15, right, is going to be somewhere in between 12 and 18. You can probably actually already find the z-score, right? So this is going to be 15. So I'm going to say, all right, let's find the z-score. So the z-score is going to be our data value 15 minus 24, which is the mean, divided by 6. So you can use the calculator if you need to, but you get negative 9/6, which is negative 1.5. All right, again, use the calculator if you need to. Now, to find the likelihood that our z-score is less than negative 1.5, because if you notice, it says less than 15, so I'm going to be shading to the left here. So I'm trying to find this area that I highlighted in yellow. So we're going to tell the calculator, okay, if I've standardized my value, tell me how much of the area under the curve is shaded less than this particular z-score. So I'm going to go to my calculator. I'm going to turn it on if it's not. Great. I'm going to hit second and then vars, which is distributions. All right. And I'm going to go down to normal CDF, which is number 2. All right. Really, the simplest way that I can teach it is normal PDF is when you're going exactly a value, so no shading, and normal CDF is when you're moving less than, greater than, or in between numbers. So we have some shaded area. So number 2 for this one. Now you can leave this in the lower. You also can change it. You'll notice that if I move my sketch over here, we are shading. Make it a little smaller. There we go. Oh, I guess I can't do that. I can move my calculator. All right, you can see that we're shading to the left. So my lower number is going to be negative infinity, which I just usually use is negative and a bunch of 9s. And then my upper number we said is negative 1.5. So if I hit enter after that, we've already standardized. So the mu is 0, sigma is 1 for this model. and we hit enter, we get 0.067. All right, so if I round that to find the actual percent, I'm saying the answer for this is going to be 6.7%. So when I think about the percent of all cars in our state that get less than 15 miles per gallon for their fuel efficiency, I'm expecting that percentage to be 6.7%. Guys, will that be the case? I don't know, right? We don't have the time or the money or even the bandwidth to find all of the cars registered in Texas and test their miles per gallon. There's just no way to do that. So this is what we're hoping or expecting to be the case. Okay, let's go to the next one. All right, so again, 24 is in the middle. We've got 30, which is exactly one standard deviation to the right. And then 20 was a little bit less than one standard deviation to the left. So I'm going to find z-scores for both of these. All right, again, one of them is you don't really need to do the work because you can see that is exactly 1. So 20 minus 24 over 6. This one is 30 minus 24 over 6. So this gives you negative 4/6, which is negative 2/3, or negative 0.6 repeating. And this one is going to be a positive 1. So now I'm going to tell the calculator, okay, so last question, I said, tell me the area that's less than 15. But now I'm doing the area between 20 and 30. All right, so this time my lower bound is going to be my z-score for 20, which was negative 0.6 repeating. And my upper bound was my z-score for 30, which was a positive 1. So this time, same exact button pushing, second VARS, which is distribution. Number 2, normal CDF. But my lower bound is actually a z-score, negative 0.6 repeating. So I just do a handful of 6s. The upper value is a positive 1. And now I just hit enter to see what we get. All right, so I get 0.589. All right, or as a percentage, 58.9%. All right, so we're expecting just shy of 60% of the vehicles to get between 20 and 30 miles per gallon. All right, let's do another one similar. Letter D says, what percent of cars get more than 40? I believe I have to go back to my original. 42 was that z-score of 3, right? 3 standard deviations above the mean. So 40 is just shy of it. All right, I'm going to find that z-score. So z-score equals 40 minus 24 over 6. So that's going to be, what's that, 16/6. And let's see, 6 goes into 16. I don't need to do this division for you. You can do it yourself. And I get 2.6 repeating. All right, so now I'm shading more than 40. So more than 40 is this tiny little percentage there. So I'm not expecting this to be very large, right? Which makes sense, right? We said if you get past 42, we would consider the fuel efficiency unusual. So greater than 2.6 repeating. So second VARS, normal CDF, number 2. Our lower this time is 2.6 repeating. And the upper is infinity, right? Going to the right forever, infinity. So let's do a bunch of 9s. And then let's see what we get. We get 0.004 or 0.4%. So very unlikely. Let me rephrase. The percentage of all cars that are getting 40 miles per gallon is very, very small. Not even 0.5% of the cars are getting that efficient of fuel efficiency. Okay, now let's change the problem just a little bit, right? Same model, not doing anything with that. But it says describe the fuel efficiency of the worst 20% of all cars. All right, so the worst 20% of all cars, that means that I need to pick a value here. I don't know what that z-score is, so I'm going to hit question mark. And it's saying the worst 20% would mean that we're shading this way. So the problem has changed in the sense that instead of them giving us the actual data value that we would look for fuel efficiency, we're going to use the computer to tell us what z-score is associated with the worst 20% of all cars, then use algebra to figure out what that fuel efficiency would actually be for our cars. So I'm going to go in and show you we're going to use a different way. I always used to think of this in high school is that we're going backwards now. So it's second vars, which is distribution. And again, I don't have a z-score, right? I need the computer to tell me the z-score. So I'm going to go to number 3, which says inverse norm, which means inverse normal going backwards. So I'm going to tell it how much area is under the curve to the left. And this is important. Notice I'm shading to the left. And anytime you do this, you want to type in the area to the left. And we're saying that this area to the left is 20% or 0.2. So I'm going to type in 0.2 for the area. I'll get that larger there. And I hit enter. And this will give me that z-score that's associated with it. So negative 0.842. That z-score is negative 0.842. So I'm going to do my formula again. But this time, I'm going to be plugging in the z-score and then using algebra to solve for our actual fuel efficiency. All right, so now I'm going to move the 6 over, and then I'm going to add 24. So doing that algebra, I'm going to multiply by 6, and then I'm going to add 24 to find this fuel efficiency, which is 18.950. All right, so the fuel efficiency is roughly just under 19, so 18.950 miles per gallon. So if you've got a car that is just below 19 miles per gallon for its fuel efficiency, you're driving a car that's in the worst 20% of all cars in the state when it comes to fuel efficiency. Okay, that's what that problem is asking. So you can see it's a different type of problem. Okay, what gas mileage represents the third quartile? Interesting question. So this is asking about quartile 3, which is going to be, right, if down here would be quartile 1. We know the middle is the median, quartile 2. So quartile 3 is up here. All right, and you learned in chapter 4 that the area to the left of quartile 3, or the percentage of data values to the left of quartile 3, is going to be 75%, right? Thinking quarters. So if there's 25%, so there's 25% or 0.25 above it, there's 75% or 0.75 below it. And remember, these calculators can only type in the area to the left. So I need to type in 0.75. So I'm going to use second distribution there. Go to inverse norm, number 3, and type in 0.75. This will give me the z-score for quartile 3, which is 0.674. So this z-score is 0.674. All right, so using my formula, I'm trying to find this gas mileage using the same mean, the same standard deviation, same algebra actually, multiplying the 6 over and then adding 24, so times 6, and then adding 24, which gives me 28.047. All right, so if you're driving around in a car that gets approximately 28 miles per gallon, that your car represents the third quartile for fuel efficiency for all cars in Texas. All right, we're almost there. Describe the gas mileage of the most efficient 5% of all cars. So most efficient would mean that it's going to be way up here, right? So z-score up here. And since we are talking about the most efficient, that means we have 5% to the right. So this right here, this tiny area is 0.05. Now be careful, right? When I use the calculator, I need to think about the area to the left. So subtracting 5% from 100% gives me 95% to the left. Oh, God, can't do that. 0.95. So let's go to the calculator to type in that inverse norm again, number 3. And I'm typing 0.95. All right, so this z-score is 1.645. So z-score is 1.645. All right, using my formula, you're seeing this problem again. Now this third time we've done it. Multiply by 6, add 24, and you get 33.869. All right, so this would be for the most efficient 5% of all cars. Okay, what gas mileage would you consider unusual? I'm actually going to go back to the very first thing we did in this problem and go to my sketch of the normal model. I mentioned this at the beginning that I believe that the z-score needs to be greater than 3 for your standard deviations away from the mean, or less than -3. Some teachers will teach that it just needs to be past 2 because, again, 95% of the data values will fall between 2 standard deviations above and 2 standard deviations below the mean. So I'm okay with either one. It's your choice. The AP exam will accept both. So if you wrote my answer, I'm going to use 6 and 42. All right. But the way I would also view this is you could also use 12 and 36. So it's your choice on how you want to do this. So I'm going to say if your car, I'll say if your gas mileage is lower than 6 miles per gallon or above 42 miles per gallon, then your car would be considered unusual. Okay, and that's just my thoughts on the matter. Okay, let's go to letter I. So on this one, for what percent of cars get under 20, we're back to one of the first ones that we did, where 24 is in that middle and 20 is here, right? So we can get a z-score like we did earlier. I think we actually found this in one of our problems between, I think it was 20 and 30. So my z-score is 20 minus 24 over 6, which is going to be that -2/3 number again, so -0.6 repeating. So we're finding that percent of cars that is under this 20 miles per gallon. So I'm going to shade under here. So I'm going to turn my calculator back on, maybe. Come on, calculator. You can do it. There we go. So I'm going to do second distribution. Going back to the first thing I told you about, number 2, that normal CDF. And my lower bound is going to be -infinity, so you can leave it like that. They've already got it in there. And then -0.6 repeating is going to be the upper bound. And I get a value of 0.252. So my z-score is, I'm sorry, not my z-score. My z-score was -0.6 repeating, but my probability is 0.252. Or as a percentage, 25.2%. All right, now, that whole idea is a lead up to the last page, okay? And this is where it can get a little tricky, so make sure you're focused on this last page. We're almost finished. So we have an ecology group is lobbying for the national goal of calling for no more than 10% of all cars to be under 20. So remember when we said the percentage in letter I for cars getting under 20 is roughly a quarter of the cars, 25%. They're saying it would be really great for our world if we could get that number to be no more than 10%. So now they're saying we need to go down here, right? And this is going to be 10%, okay? And so we're going to find that the standard deviation is not going to change, but we can get a new average, a new mean that's going to make this work. So let's find the z-score associated with 10% of the values below it. So I'm going to do the inverse norm, which is number 3. All right, so type in 0.1. And I'm going to get -1.282. So -1.282. So now watch how this works when I plug into my formula. So I know my z-score is -1.282. We have 20 is the value we're looking at for our actual fuel efficiency minus a new means, right, new mu, over 6. So in terms of viewing my algebra, I'm going to go ahead and multiply that 6 over, so times 6. And then I'm going to subtract the 20. And I know that it's going to say my answer is negative, right? But that's equal to the opposite of my new mu. So my mu, just going to make it positive here. All right, so if I make that mu positive, I'm going to get 27.689. So 27.689. So you can see that we're asking cars, I guess car manufacturers, to make their cars over 3 miles per gallon more, almost 4, over 3.5 miles per gallon more fuel efficient on average with this lobby. Okay. Now, car manufacturers say, okay, we're all on board with that, right? Helping out everyone, helping out the planet, but they think they can only get to 26. So, okay, what would be a standard deviation? So a new standard deviation we could use that would allow us to achieve this goal of only 10% here, right? Remember, this is 0.1, only 10% underneath it. So that same z-score, I don't need to find it again, of negative 1.282. But now watch what happens when I use that formula. I'm doing 20 minus, they said they could get 26, but I'm going to solve for a new sigma. All right, so now I'm going to move the sigma over with multiplication and then divide the negative 1.282 to the other side. So essentially, I'm going to be doing negative 6, right? 20 minus 26 is negative 6, divided by that 1.282 number right here. And when I do that, I get 4.682. So my new sigma is 4.682 miles per gallon. So essentially, what we're saying is that they are going to need to make the spread not as spread out, right? Previously, it was 6 miles per gallon, so almost 1.5 miles per gallon less spread out. So I know this is the end of the problem, but let me just kind of show you what that would mean. All right, so if I draw another curve here, and we've got 26 down the middle, and I'm going to go 1, 2, 3 standard deviations both ways here, and I'm just going to be doing using this new standard deviation, so 26 plus 4.682 to get 30. You don't have to do this, right? I'm going to try to bring this all together before I finish the video. Add another 4.682, 35.364, and then finally plus 4.682 is 40.046. And I got a little jumbled there. Let me go the other way. I got 21.318, 16.636, 11.954. All right, so what I was trying to prove to you is if you go back to the original, right, if you go back up to the letter A, which was going between 6 and 42 with our original model, now we're saying that the new min, we get to it. The new worst fuel efficiency is just below 12 is what we'd expect for our worst ones. All right, so that's good in the sense for consumers that we don't have any cars that are getting single digits. In theory, yes, you could have. That would be possible. Outliers or things that would be unusual. All right, so that's helped us in the sense of we've achieved a greater fuel efficiency for our worst cars. But the flip side of that is now we're not going up to 42. We're going up to roughly 40. So we've made those cars that were really, really fuel efficient, and we brought that a little bit closer because remember, we're shifting even though the mean has gone up a little bit because the standard deviation has shrunk a little bit, that's causing our values to not be so spread out. So it's up to you not to you, it's up to people and people doing this for their jobs, how much they want to kind of balance those two things. All right. So, kind of to sum up, make sure you're practicing. I know there's some exit tickets, there's some IXL links. Make sure you're practicing, especially those button pushing, for how to calculate these percentages, get these z-scores, go inverse norm, normal CDF, all those different things using the calculator. Good luck.